this is question 10. We just need to convert 121 miles into kilometers here. It tells us that 1 mile is equal to 1.61 kilometers. Therefore, we're just going to multiply. And we get 194.81 kilometers. Convert 1 hour into seconds. Well, we know that there's 60 seconds in a minute. Therefore, if I multiply each of those seconds by another 60, because we know there's 60 minutes in an hour, we're going to get 360 seconds. Sorry, 3,600, I just multiplied wrong. And we know then we're obviously going to have to do something with these numbers probably in the next part. Yep, so use answers parts I and II to convert 121 miles per hour to meters per second. Now obviously to do speed we do distance over time. That's really kind of what we're doing here. The 3,600, that's okay, that's in seconds already, that's what we want, but we want meters per second. Now we have 194.81 kilometers, so we need to convert that into meters first of all. Now there's 1,000 meters in a kilometer, therefore we're going to have to multiply that by 1,000 in order to change it into meters. That would be 194,810, and that's what we're going. That's the number we're going to put on top. Then 194,810, and we're just going to divide those two, and we get 54.11, and that's meters per second. Now part B, we're doing surface area of a tennis ball. There's going to be a formula for, well, it's of a sphere obviously. When we have any kind of a ball there, it's going to be a sphere. So I'm looking for a surface area of a sphere formula, and that is 4 pi r squared. 4 multiplied by pi multiplied by the radius, which they've given us of the smallest ball, 3.27, and we have to square that as well, and you're going to put all that into the calculator, and that's 134.37. Then a cross section of the tennis ball, so now it's just a circle. The ball is made up of an air-filled centre. The external radius R1 is 3.4 and R2 is 3.1. Find the volume of the rubber layer. Well, what we're going to do is we're going to find the volume of the whole thing, and then we're going to subtract the volume of the inner circle of this bit in here. The formula for volume of a sphere is 4 over 3 pi r cubed. Now I'm going to do that twice. I'm going to do it with the two radiuses or radii that are there. 4 over 3 pi multiplied by 3.4 cubed minus 4 over 3 pi 3.1 cubed. And you could put all that in the calculator together. You could do the first bit first if you want, but it should do the whole thing together for you. And you should get 39.85 centimeters cubed in the end. That's taken the full tennis ball, the volume of the full tennis ball, and then we subtract the volume of this sphere in here, this white bit in here, and that will just leave us then with the little rubber bit. Therefore that 39.85, that's the volume of the bit of rubber. Now part D, show that H is equal to 20.4. The The radius of each tennis ball is 3.4. Therefore, if you're to look into the shape there, that distance there is 3.4. So if we add on this bit here, that's 2 times 3.4. And then that's 3 times 3.4, 4 times 3.4, 5 times 3.4, and 6 times 3.4, which is there's 6 radii basically up the can basically, or whatever it's called, cylindrical container. Therefore, if I just do 6 multiplied by 3.4, it should give me 20.4. You can just double check that on the calculator, but that's enough to show it. Calculate the volume of the cylinder. I have a formula for volume of a cylinder. It's pi r squared h, which is pi multiplied by the radius of the cylinder is 3.4 squared, because it's that distance there that's marked in already. That's just it's the same as the radius of one of the tennis balls. And then our height, we said, is 20.4. And it's just using that formula now and just putting it into the calculator again. And we get 741 centimeters cubed. Now for this last part, the height of the box will still be the same. It's 20.4 as the cylinder above. The side, because it's still 2 radii, so it's 3.4 plus 3.4, so that's 6.8. The bottom has to be, and then the side has to be 6.8 as well. The surface area then will be 2 times, well, the front of that box is 20.4 multiplied by 6.8. That includes the front of the box there and the back of it as well. Plus 2 times, then the side of the box is 6.8 times 20.4. And then the top bit there and the bottom, if we're to take them areas into account, it's 2 times 6.8 times 6.8. And that all together then will give us the full surface area of that rectangular box, which is 64736. And that is in centimeters squared. And that's it then. That's all for that paper, I think. And that's all. Yeah, that's all for that question and all for that paper.